Hi guys, question 3, the first thing we have to do is draw the graph y equals sine x plus 60. So you should know that this means we're going to, oh that's a horrible colour, move this left. So we're going to move it by that translation. Okay, and here's our range, minus 360 to 360. Now before, I'm just going to ignore this just for the minute because our normal graph, and you know, in this test you get so much room, so why not make two sketches? I'm going to make two. Our first one we know goes from 0 to 180, oops, and then 360, and we know it continues in this fashion here, so that'd be minus 180 and minus 360. So that's your normal sine x. So if we were to draw a new axis down below, here's one I made earlier, and we're going to take all these points and move it left 60. So this one is going to be 120, this one's going to be 300, oh that's a 0, trust me, that's going to be minus 60, minus 240, I'm losing my scale a little bit because I just want to fit this on, and this minus 420, and you can see here I've actually gone past the scale here, and that's purely because I like to start my sine curves from like this 0 either here or here. Just find it much easier to draw. Okay, so I'm going to quickly draw that in for you. I'm sure you can do a much better effort than me on this graphics tablet, but just try and make sure that these two points here are the same level, and your lower points are at the same level as well. Okay, so they've pretty much got it done, but we have to also give the coordinates. So let's start off by doing the x coordinates. So x coordinates, pretty simple. We're just going to write down all of these, but we're not going to include this one because it's outside of the range. So we've got minus 240, 0, minus 60 and 0, 120 and 0, and 300 and 0. Okay, but we've also got y coordinates. We've got this y-intercept here. Now to do this, you should know that this is the line x equals 0, so we can put x as 0 into there. So what we end up with is y equals sine of 60. If you type in what sine of 60 is, you get root 3 over 2. So therefore the coordinate is 0, root 3 over 2. Now you can write this in decimals. I believe that's 0.87 to 2 decimal places. It's just way more accurate to write it like that. Okay, so I'm just going to tidy all this up so we can still do B on the same screen. So for part B, we have to work out the x coordinates where this curve meets the line y equals a half. Now, if I just get my straight line tool, you should know that the very top of this curve is 1. So what we're actually doing is, let's say that's y equals a half, it's pretty accurate. We're looking for the x coordinates at this point, this point, this point, and this point, and possibly this one as well. Okay, so to do that, to find out where two lines meet, we put them simply equal to each other. So we're going to have sine of x plus 60 is equal to a half. So we're going to solve this now as a simple trig equation. So this isn't just sine of x, so we have to work out our new range. So instead of x, we're actually having to add 60 onto everything. So instead of 360 up here, we're going to have to add 60. So we're going to be going all the way up to 420, and instead of going down to minus 360, we're going to be going down to minus 300. So let's start off by drawing our cast diagram. There's quite a big range on this one, so C, A, S, T. Now let's draw on where sine is positive. You can see here that sine is a half. Okay, so that means the sine is positive, and it's positive in this quadrant here and this quadrant here. When you draw these, please try and make sure that they're roughly the same angle because they are representing exactly the same angle. Okay, so bear in mind this is 0 and obviously 360, and if we go around again we get up to 720, and we're going to have to be going past 1 full rotation up to here. So we have this option here that's going to give us a value, and we also have this one here. So that's within the first 360. Now, depending on what this angle is here, is whether we can go around and meet this again. And we've also got to go in the negative direction. What I'll actually do, I'll draw a separate one for that. I just think it makes it really complicated when you do them all in one diagram. So we'll just do this bit first. Okay, so let's grab our calculator and work out what x plus 60 is. So x plus 60 is going to be the inverse sine, there you go, of a half. And that is 30. So it means that this angle in here is 30 degrees, and therefore this one is 30 as well. So we have x plus 60 to be 30. All the way around here, well, if that's 30, this obtuse angle here is going to be 150. Now, there's 360 on this line here, but if we go up, we can get to another one. If we add on 30, we're going to get to 390, which is in our range. So what I always like to do is match my working. So this green arrow, that gave me that one, and I like to do that one in a dash that represents I've gone past the 360. And I've got this 150 from this blue line, which was there. Okay, so that's it done for this part of it. So let's draw another cast diagram just here. C A S T. Let's put these lines in exactly the same place. So I'm trying to get a straight line tool. Just thinking about it. There we go. And if we mark on those angles, which we know are 30 degrees, but this time we're going to go around to minus 300. So we've got this option this way, and we've also got this one here. Okay, so this is 0, and this one, remember, is minus 180. So if we're adding on 30, we're going to have minus 210. And if we're taking off 30 from 360, we're going to get 330. Right, I'm going to write it down there. It's always worth writing it down in this case, because you should have noticed that x plus 60 is minus 330. But of course, to find x, we're going to take off 60 in a second. So I'm just going to write these out in a nice, neat line, just in this bit of space over here. Okay, so I've just written down here x plus 60, and that's all those angles. Always write them in ascending order. And now we've got to take away 60. So if we take away 60, you can see here that's minus 390. That's gone out of our range, so we're not actually going to include that one. Take away 60, we're going to get to minus 270. That's within our range. Take away 60, we're going to get to minus 30. Take away 60 from there, 90. And 330. So let's remember these are all in degrees, so we should always, I should have put them up here as well, have our degree symbols. It's quite a long question, lots of things to do, 2 cast diagrams, but hopefully that made sense to you all.